Hi everyone. I would like to start our discussion today about domain-driven design using ZIO. So if you don't know what ZIO is, basically it's like implementation of IO monads in Scala. And I want to talk about how to structure our project if we are using ZIO in our Scala project. So basically this talk is mainly about this book, Functional and Reactive Domain Modeling. So back then, this guy who wrote it, the bassist goes, he doesn't use ZIO because we don't have ZIO back then. And I still remember it has lots of cats effects. It also says something about functor monad inside the books, but no ZIO. And eventually I saw a blog of him being using ZIO for his domain-driven design kind of project. And then I look at it and then I try to implement it in my project. And here now I want to discuss something about it. So now let's talk about domain modeling using ADT. Okay, ADT is algebraic data types. And then also we are talking about making invalid state unrepresentable, which is quite interesting. We also talked a lot about algebra. Okay, so our domain service is now based on algebra. And then also I want to design a project structure, and then the goal is with hexagonal architecture. So now ADT, algebraic data types. It contains of product types and sum types. Product types being a multiplier like this, okay? And then sum types is like a plus because it's like summation, right? So for example, so we have a data type. Basically, this operation plus and multiply is actually an operations between data types. So if you want to merge two data types, becomes something else, so you can using plus or multiplier, right? So color is only like an enum. So we have red, green, blue, and then direction we have north, south, west, and east. Okay, if we want to combine these two types using sum, like color plus dir, so we have a new type which the value could be either R, G, B, etc., or maybe E, right? So it becomes like you are merging them together, and now not only you only have RGB because now the color also have direction in this new merge type. But what about if I merge these two types using multiplier? So the result type is you have both, right? You have R and N. Okay, so the combination you might end up using having R and N, like red and north, or maybe green and north, or red and west, whatever. So you have many combination out of it. Okay, so for example, how to implement sum and product types in Scala. So in Scala, to model the trade directions, we can use case object or enum or whatever. For simplification, let's just use enum. So we have N, S, W, E, all extends from direction, and then also color, RGB, extends from color. So if you want to merge these two together in Scala, so if we want to use plus, okay, so we can use either, okay. But like why it is called plus? Now, actually quite simple, okay, because if you plus them together, if you use operation plus, you will end up having 7 combinations of these enum. So for example, color is the original combination is 3. It's either R, G, B. Now if you plus them together, it might R, and then it also might S. So now it's plus 3. Now you have 7 addition. You have 7 combination, right? But now if you are using multiplier, direction times color. So in Scala, for example, it's a tuple, right? Like direction, comma, color. So 4 and 3. All of this combination is not only 7 because now you multiply it, now it becomes 12. So maybe B and W, R and W, etc. So that's why it's called sum types and then product types. Product is multiply. For example, now study case. Please model a data structure for registration. User can register either by using PIN number, phone number, or email. So first, identities. Let's model identity. So identity can either PIN. So PIN is integer, okay? And then phone number. So I just plus it, either integer or phone number or email. So I can just plus it together. So all these 3 merged together becomes identity because now you only have either one of these. You cannot have both integer like PIN and phone number. You can only have one of this, right? So that's why we are using some types. So identity is either of these. But a user have both identity and string. So we cannot just plus identity and string, but we need to multiply them. So identity times string. So that's user, because user has both identity and string. So how to model this in Haskell? So this is Haskell. Pretty much the language is based on ADT, so that's why it's very clean here in Haskell. So identity is like pin of int or phone of string or email of string, okay? And then what is user? So I can use tuple, but I'm using a record here in Haskell. So record has a field name. So user identity, what is the identity? The type of identity is identity, and then the type of name is string. So basically I'm producting identity and string by using a record, right? Or tuple or record, same thing. Now I'm instantiate a user. So user, what is a pin? 666. And then what is a name? Name is name. So the same thing in Scala is quite more verbose, but it's actually the same way. In Scala, we implement some using object-oriented programming. So we are using identity as a base object or the trait. And then everything here is actually derived for identity. So pin is identity, phone is also identity, email is identity, and pin is integer, phone is a string, and then email is string. And then user is a product type, so we can use a record case class for product type. So user have both identity and name. So we instantiate user. Okay. So I just introduced you to this concept about ADT, but probably we already know about it, right? Now comes the next question. So what's the point I'm telling you this, right? Okay, so I want to emphasize on one thing. Making invalid states unrepresentable. Okay, that's like one thing I want to emphasize. Okay, so for example, now user. So user can only have either pin or email or what else? I forgot. Yeah, email or phone. Okay, so I cannot have user that have both pin and phone. It is impossible because it is a sum, right? So it's the identity is either of them. Okay, so that's why like I want to make sure that user is always valid, and I want not giving a chance for any invalidity of the user state. So that's my strong point here. So let's go. Let's see this example without ADT. So usually it's very common for a user, for a programmer to implement like the user can either have pin, phone, or email. So it has either optional of in, optional of phone, or optional of email, right? But because we are coding in this way now, we can have this state now. Because what about if I'm doing user and none, none, and none? Okay, so now we are instantiating an invalid user. So I don't think this is a good habit for us programmer in Scala, right? We in Scala we like about type. We rely on type system. We don't like this to happen, right? And because we are giving a chance for any invalidity, now we need another function to make sure it's validity. So we need to create this function. But if we are using like ADT practice, we are not introducing this three option, but we are using some types instead. We don't need this validate, right? Because now every user is guaranteed to be valid. Okay, nice. Now let's see about how to make sure the validity in Scala. For example, I have a user. So now my user is always valid. First, I will make sure that our identity, the only way to create our identity now is using this factory method. So we have this pin, okay? So I want to create a new pin, but please use this function instead. Don't use pin directly. Don't instantiate pin directly, but please use this function. And then this function will return either it's an error or it is a successful and we get the pin. For example, if we put 666 and this will be true, and it will be error because 666 is a very restricted number somehow, right? And then if we are giving a negative number, it will be negative, right? So pin can only have a positive value. So this is how like factory methods in Scala. So if you want to validate any, not validate, actually, if you want to create a valid case class, so we usually using this kind of factory method. And then also for user, So user, we can also have that like I want to create a new user, so I will use this create, okay, and then now by using this as private, okay, this private, so nobody can access this constructor directly. So the only way to create a user is by using this create method. And now if we see any user, it means always valid user, because this is the only way to create user. Okay, so that's the idea of like a strong validity. So now we will talk about algebra. So where does it comes from? So people might think that algebra is like Arabic names, and probably some Arabian guy's name back in the past. So actually it's almost true, because this guy's name is not algebra or not algebra. This guy's name is very famously known as algorithm. So algorithm in Latin is called algoritmo. So algorithm, you know where it comes from, right? So Al-Khwarizmi is called Al-Khwarizmi because he came from Al-Khwarizmi in Uzbekistan, but he lived in Baghdad during the reign of Al-Ma'mun. So his real name, because Al-Khwarizmi means someone from Khwarizmi, right? His real name is Muhammad ibn Musa, okay? And then also Arabic name, also sometimes they be called by its kunya, like Abu Ja'far he. So Abu means the father of, so he's the father of Ja'far. Probably his son names is Ja'far, okay? And yeah, so he lived during Khilafah al-Abbasiyah. So people usually, historians usually see that as an Islamic golden age. But unfortunately, the Islamic golden age, one of the main reason why it's come to an end, because of the invasion of Mongol. So Hulagu in 1252 or 1256 somewhere, they conquer Baghdad and just destroy everything, including the Baitul Hikmah. So so Al-Khwarizmi is one of the like the CEO of that Baitul Hikmah, which is the great library. So yeah, so he lived there 780 CE, and actually his works for this particular algebra is very influenced by this Indian guy named Aryabhata. So Aryabhata, he lived in Gupta Empire long time before. So now how algebra comes from then? I haven't seen any algebra yet, the name, okay? So because this guy wrote this kitab, this book. So look at this, like Al-Kitabul Mukhtasar fi Hisab. So Al-Kitab means a book. Mukhtasar is like a comprehensive. So it's a comprehensive book for calculating, to hisab, to calculate algebra. So here is algebra wal muqabala. So because of this book, now algebra becomes like quite a name back then. Okay, so that's algebra. So what is algebra then in our context? So algebra means something that has an operand, has an operation, and has laws. For example, arithmetic. So operands or data, right? So what are the data for arithmetic? The data are numbers. 1, 2, 3, 4, whatever, etc. What are operations? Plus, minus, divide, whatever. Okay, I mean, etc. And then what are the laws? So the laws are many in algebra, in arithmetic algebra, like commutative, a plus b equal b plus a, or associative, like these guys here, this equation, always held true. So that's why it's called laws, something that always held true. In math, actually, there are many algebra. It's not only arithmetic. So for example, we also have Boolean algebra. The operands are either 1 or 0, and then operation are maybe and or, and many other operation like SOR, okay? So, and Boolean algebra is not arithmetic algebra. They are different algebra, right? And what about in our application? Then our domain also has algebra. Yes, if we are defining it to be. So let's see, we are making a banking application. So in our banking, our operand will be an account, amount, right? A balance. That is actually our model. Sorry, in algebraic terms, it is our operand. What about the operator? Okay, so I can open a new account. So it's an open. So like in Scala, we have operands here, account, amount, and balance. And then we can do the operators. So operation are open, close, debit, credit, and balance. Okay, so that's actually our algebra. What about the laws? Okay, so the laws is, for example, in account, if we take a credit for a certain amount of money from a particular account, and then we put the money back. If we credit and we debit an M amount of money from a particular account, so the the amount of that account will be the same before and after all of these operations happen. So that's actually our loss. And in Scala, the loss means like the implementation of the loss is actually when we are creating our unit test. Okay, so this is like a very fancy way to create a unit test by using a loss. But usually I seldomly do this because I don't even know our business logic laws. So yeah, if you don't know the laws, don't force ourselves to create the laws. Just try to define the algebra and that's it. Let's just continue coding without using laws. We can also use unit tests without laws, right? So yeah. And let's design a project structure. So layers will be explicit. We also want to discuss about how to create a config in our project. Okay, so let's do something before I go on to, deciding to discuss this. Let's talk about a layer. So I want to talk to you something about layer. So for example, let's say we are creating a new layer. So now everything inside this box is located in this particular layer. Okay, so now let's say we are creating a classes, like some classes inside this particular layer, and then let's say this is a core layer. So we meant this layer as a core. We meant this, and then we put something classes that has something to do with the core or business logic. So when I say core, it means business logic. And then also let's create something else, maybe data access layer. Okay, so data access layer here. So I will create some kind of classes. And usually upper layer can only access lower layer. And I don't want to discuss how come data access layer located in the upper layer because I have discussed this in previous talk. So yeah, so it's like the DDD way to do this. What is that called? A data access layer. So now data access layer is located upwards than our core. So this is how we do it. And then also we create another layer, maybe UI layer. Okay, so now this is a UI layer. So everything that has thing to do with the UI, maybe HTML. Let's pretend that this is like the ASP.NET way. So usually we still create a mixture of HTML and then our classes. So usually our UI will access whatever business logic in the lower layer. Okay, that's our project. Even though sometime, yeah, we might accidentally do this, might be, maybe not intentional, but like usually lower layer cannot access upper layer, but that happens accidentally, and we will talk about this, like how it can happen because of config. So config is very confusing things to discuss. Let's talk about config. But this is like the first way to talk about layer. So you create a layer because you have intention. I want to create a core layer because I meant it to be core. Okay, so this is like intentional layer. But let's this is like the second way of creating a layer. So now you are just creating a bunch of classes. Okay, and then these classes each they are accessing each other like this. So even though you don't have layer, but now based on the way it's accessing each other, so we know that this is like the first layer, this is the second layer, this is the third layer, because of the if we order based on the dependency, so we will end up having these three separate layer, right? Okay, so even though like you have like a very messy kind of something that has circular dependency, and then your classes is like have this kind of messy arrows, you will end up like, because these three together they have a circular dependency, basically is in one layer, and then also you have this guy accessing this, so this is like in upper layer. So even though you don't have any intention to make any layer, but if you order it, you will end up having a layer. So that's my point now. Okay, so my strong point now is I want, if I am creating a layer, okay, I have two conditions. First, I want my layer is intentional, and I also want it to be ordered consistently. So I don't want in my layer to have this. What is this? Like lower layer can access upper layer. I don't want it to be happen. Okay, so this is like for the rest of the presentation, this is like what our main topics are. Okay, so now I want to tell you something about something not ideal things that might happen. This is upper layer. influences lower layer. Okay, so for example, this is our core or business logic. Okay, and then this is our data access layer. Okay, so now employee. Okay, employee has several fields, code name and birth date. Okay, and then I want to save employee, so I need an employee repository, and employee repository is located in the core, but only the trait. So the traits is in the core, so this is like employee repository. Okay, employee repository. Okay, but the implementation is located in the data access. Okay, so this is the employee EF repo here. So basically, this is extends. This is like derived from employee repository. This is only the trait, right? So that's actually how we usually do it in DDD. Okay, so now, so let's see, our employee repository are using this very cool framework called Entity Framework, or EF. Okay, and EF, we have this context, and then we want to save the employee, and then we can just call this context.save employee, and automatically it will save our employee to database without require us to manually write SQL query like insert into, etc. Okay, how it does that? Maybe it can derive from the field name automatically, and yeah, very cool, right? But we have a problem here because in EF context it's very demanding. EF context says to us, if you want to implement EF context, please put in your table, okay, in your table, one integer for primary key, okay, and then because of that demanding, okay, demanding things from EF, we ended up adding one more field here, ID. So this ID doesn't have anything to do in real world. There is no employee ID. I mean, employee ID in this real world is called code, right? Okay, so we have code in real world, but ID integer, we don't have it. We only put it for the sake of database, for the sake of entity framework. So that's why like this is upper layer influencing something to the lower layer. So usually I don't like this to be happen, but it might happen somehow. But yeah, let's try our best to avoid it, right? If you have another option to avoid it, just avoid it. Even though, yeah, it might happen, okay? So that's one example for influencing by upper layer. Okay, now config. So config is always confusing. Okay, so now let's see our application. So we have product service here in our core. So we have core, we have infra. So in our core, we have product service. Okay, and then we have this method called create product. Okay, and it will validate. Create product is like the input is name and price. Okay, and then we want to make sure that the price is not too high. So that's how we have this validation here. Price is greater than config.max price. So it will be an error. So left price too high. Okay, otherwise it is a right of employee. So this is successful. So what is this config then? So it's config. If you want to create instantiate a product service, so please provide us with the config. So that's how it's taken there, config, and then we declare that the config there, product config, max price integer and max quantity is integer. So now what's the problem? Actually nothing. We haven't seen any problem yet, because maybe you might say we cannot have a config in core. Actually nothing. If we see this is only max price and max quantity, right? It's only a bunch of value, so nothing there will harm us. And also they are both business concern. Max price, max quantity, they are both business concern. So they are totally valid to be held in core. So that's why it's still okay. Now let's see our infra here. So our infra, we have a product repo if we want to save our product. So we create this product SQL repo. So if you want to create this product repo, so we also need this DB class, because we are using a framework, and this particular framework using DB. So if you want to save this product, you can just call db.execute SQL blah blah blah, right? And how to create this DB? So if you want to create this DB, you need a connection string and pool size. Okay, so this is it, like DB connection string and pool size, and then this connection string and pool size, we use that at config in the input, right? So I want to create a DB, and then the input here is a config, DB config. Okay, and then we are ended up instantiating the DB with the config, both const string and pool size. Okay, so now where this DB should be located. Okay, so maybe now it's located here. So we created here because it needs it, right? So this is our DB config. But now I want to make something very cool. I want to put all of these values. Okay, I want to provide all of these config values from a file, from a config file. So I want to, in order to create that file, I need to create a root config which has everything. So in my root config, I have product config. I also have db config, okay? And then I can just call load, like cool config.load, okay? And from this file, and then automatically all of the values of root config, okay, including its children, now fed up with the value taken from the file. Very cool, right? But in order to do that, of course, like root config needs to access db config, and because core is located in the lower layer, so I need to put it down here because I need to put it down. Remember, you cannot access something that upper layer, right? So I put it down here. So now we have these things. So the problem comes here now. Okay, so the first problem is like our core now has a particular framework. Usually I like my core layer to be very pure. It's only have Scala. And because we are using ZIO, for example, to be honest, we are not even having any discussion about ZIO yet, because ZIO discussion will be later in the demo, okay? So now, so usually in our core, I don't like to have any particular dependency on particular framework. But now our core becomes dependent to this cool config framework to load the config, right? So that's one unidealism. And then the second one is our core now know db config. db config is connection pool size, connection string. What is this connection string? Has to do with our business logic, okay? Of course, nothing. So now this is an idealism. I don't like this to be happen, but it happened. So how to avoid this? Okay, so the first proposal to solve this problem is okay, so maybe my other argument is like, but db config is only config. It's not a logic, right? It's only a value of connection pool size. It is not a method of accessing SQL or something, right? Yeah, I mean, yeah, that's maybe valid, but I still somehow doesn't like it. Pool size, connection string is like you are putting something that not there. Okay, so based on SRP, single responsibility principle, so core is core, infra is infra. So core, you cannot put anything unrelated to core in core, right? So I don't like this. Okay, so maybe our first proposal is maybe what about introducing an uppermost layer? Okay, the boot layer. So now I in our app layer. So in our app layer, maybe in our main, it will try to load the config files, and then it will fill the values, the children. Yeah, now it's cool. The application layer can have that. But the problem now is our product service still depending on config, on product config. Now our lower layer will accessing upper layer. So yeah, I oftentimes like see this happen. Okay, so because yeah, I mean config is very confusing. So now how to solve this? So this is my final proposal. So let's product config be here, because who need this? Then oh sorry, product config is here, right here. Product service, product config. Okay, so product config, product service need product config because he want to know the max price. So I'll put it here, and let's just be there. Okay. What about db config? Yeah, db config must be here. Okay. And then what about root config? So root config is in our app layer or boot layer. I will argue that our app, what is app layer? I will tell you what is app layer next. But now we have boot layer, which is like the topmost layer. And then our boots will know everything. So even like your root config now is very totally acceptable. Our root config to access both product config and db config, which is located in lower layer. So it's totally valid here. And then and of course, like your boot, if you just put any fancy framework in your app layer, that's also totally valid. So this is like my final proposal to as a solution for this config confusion. Okay, so now I want to talk about this particular application that I will demo in a moment. So basically, it's an application to schedule an invoice. Okay, so first our core Okay, so our core will have three algebra. Our core will have three algebra, so it is like invoice. We also have subscription, and I have subscheduler. Okay, so subscheduler is actually algebra to add new billing entry. So that's, let's say, like, hey, please bill this invoice in a particular time in the future. So I will just add a billing entry, okay, to subscheduler. I mean, the operation is located in subscheduler, and then it will somehow store in the particular storage system. Might be DynamoDB, or might be in memory repository. Okay, so that's basically what the business logic we are trying to build here. So of course, if you see this gray box, it means one project. Okay, but it doesn't have to be one project. Maybe it's only a folder, it doesn't matter. The boundary doesn't matter. But for this particular application that I will demo, it is actually one sub project. Okay, so core, we only have one sub project of the core. Okay, and then of course, like subscheduler, I have just mentioned to you about subscheduler can save a schedule entry in the future, right? So how does it save? Because I'm saving it using maybe DynamoDB, for example. So DynamoDB, so in subscheduler, I have a repository called like a billing entry repository in subscheduler, but it's only a thread. And then the implementation must be in this layer, upper layer, because my core, I don't like my core to have particular technology things. Specific technology is not in the core, but it should be in infra layer, okay? So now I create a new project called infra.repo.dynamodb, right? So now my project naming scheme must be very clear. So infra means like, which layer are you, okay? And then dot, what are you trying to do? Like whether it's a repo, whether it's a client, okay? So it's a infra.repo, and then dot particular technology, dot DynamoDB. So inside this sub-project, all of the implementation of the trade repository in the core, it has the implementation here, okay? So now, invoice and subscription is actually, we are just calling that to other microservice. So we don't need to implement our logic here. And then also subscription, we need subscription to revoke, okay? To revoke a subscription. So we don't need a particular logic, because in our case, this is handled in other microservice. So now in the core, we can just create algebra, and then without the implementation. So remember, algebra is only a thread of operation. So the implementation is not here. Let's imagine that the implementation is somewhere else in other microservice, okay? But to call other microservice, we need a client. That's it. So that's why we still need another project called infra.client.http, okay? This is a new sub-project in the upper layer. So now our invoice and our subscription, it has the implementation of those two HTTP client, okay? So we have that too here in infra.client.http. And then maybe next time we are not using HTTP anymore. We are using gRPC. So we can just create a new project called infra.client.grpc, and then we are implementing those two algebra, invoice and subscription. So this is like our HTTP. Okay, so this is DynamoDB, and of course, like for the sake of like playing around, okay, I sometimes create a repository only memory. It doesn't use any DynamoDB. It's only using map. So it's a kind of dummy repository, but it's kind of handy for testing purpose. So I create this. So in our case, in this project, we only have one thing need to be put to the database, which is called schedule entry, right? So we only need one repository. So here, so inside this project, I only have one implementation of billing entry repo, okay, which is here. It's a thread, so the implementation here, but this is only a dummy implementation. And then here is like a DynamoDB implementation, okay? And now we also have app. So this is infra, and we have also app. So if you notice here, what is the name of this layer? The name of this layer is app-infra, because they are both actually in the same level, okay? Ordering wise, because look at this. What layer is this core? Core is level 1, because core doesn't depends on anything else, okay? So that's why it's called layer 1. And this infra client HTTP, why it's called 1? Because it's accessing core. Okay, so it's it's level 2, right? Because it's accessing core, and core is level 1. So now it's level 2. So because all of these guys here actually only one step away from the core, so that's why now it's a level 2. Core level 1, app and infra both level 2. Okay? So usually people might think that app has a higher layer than infra, right? But no. No, they are in the same level, like level wise, okay? They are the same. Okay, so in my project, I have three app kind of application. Okay, they are all actually using the same core, but actually like the purpose of the application are different. So that's why I have three application. Okay, so first I have a CLI application. Okay, so again, how I name this project, app.cli. What is the purpose of this application? Okay, so maybe it's just a normal scheduler. I want to see what are the schedule that is due time, so I can see that. I also can put a new schedule. So yeah, so I can use CLI there. Okay, and then this, please don't get me wrong. Usually people will think that CLI will do a HTTP call to some RESTful server, right? But in here, it is not. So our CLI will call directly to our core, so no CLI needed. Okay, is it useful? Yes, it's still useful because our repo is DynamoDB. Okay, so if we are calling our subscheduler, and then subscheduler will eventually call to DynamoDB, and DynamoDB will call to the AWS. So now my CLI can see all of the entry in DynamoDB in AWS. So it's quite handy, right? Okay, so that's for CLI, and then we also have a HTTP server. So again, app.api.http. Maybe this is too verbose. Maybe I will rename it to app. Maybe RESTful rather than api.http. Okay, and then of course, like the last is like what the purpose of this application. So it's like scat ingest. So it's more about adding more schedule for ingesting a schedule, right? So it will also have a relying upon this subscheduler algebra in core. And also we have agent. So agent is like it will check everything that has due in the past. So maybe every 10 seconds it will fire and check if we have a billing needs to be processed. So this is basically an agent. Okay, another application again, because the purpose are different, but they are accessing the same core. Okay, so that's our app. And please remember, app doesn't necessarily can access directly to infra. They don't know. They only know core. Okay, so that's why it's called app-infra. Okay, so then now for booting purpose, I create this extra layer, because now if you ask me like how app CLI, if I want to put something, so how can it communicate to infra repo DynamoDB, right? How to wire them up together. So this is like the boot. What boot does is they wiring up all of the things together so your application can start running. So boot knows everything. I know about this client HTTP. I know about infra repo DynamoDB. If your application need it, let's say my application need to be in repo DynamoDB, so you will just wiring them up together in boots here. That's how it will be doing in our particular case. Yeah. So now every application has extra boot layer there. Okay. So I think this will be clearer if we see the actual implementation. So that is our time for demo.